Welcome back. We're now on lesson 6, and we're going to talk about equations with decimal numbers first. So let's just jump in. These are pretty easy. This should be a review for most of you. If we have 0.003x plus 0.4 equals 2.05. All right, the first thing we want to do is get rid of the decimals, right? So we look and see what our greatest decimal place is, and that's going to be tens, hundreds, thousands. That's the biggest decimal. So we multiply everything by 1,000, right? That just means we move it back 3 decimal places. So that becomes 3x, goes 1, 2, 3, plus 1, 2, 3. So that's going to be 400 equals 1, 2, 3. And there's our problem. Okay, and the reason we can do this is the multiplication property of equations that says if we multiply everything by the same number, we can still get the same answer. It still keeps the equation true. So that's what we're doing. We are multiplying everything by the same number. We're just getting rid of the decimals. It's just making it easier on ourselves. So we're going to change sides and change signs. So we have 3x equals 2,050 minus 400. And that's going to give us 3x equals 1,650. We divide both sides by 3, and we find that x equals 550. Pretty straightforward. All right, and that is our problem. Ta-da! All right, so we have another, let me see, I think I can do it here. Oh, this one is a word problem using decimals, so I'm going to need a little bit of room to do this. I think I could do it here. Let me try this here. All right. All right, here is our word problem. The students found that 0.015 of the teachers were either brave or completely fearless. If 300 teachers fell into one of these categories, how many teachers were there in all? All right. So 0.15 can be used as a percent. Okay. So we know we have 0.015 of all the teachers. So that's going to be of 1, because this decimal is a percentage of 1, and that equals, first of all, before we do that, let's talk about getting rid of this decimal. So we have 1, 2, 3 decimal places. So we need to transfer that into 15 over 1, 2, 3. So 1, 2, 3, 1, 2, 3. That's how you do it. You count the number of spaces, and that's how many zeros you use. So 15 out of 1,000 is what we're looking at. So 15 out of 1,000 teachers were brave, then 15 is representative of the 300. So we put that on the top, and we put x on the bottom. Now we can cross multiply. So let's do 300 times 1,000. That's going to give us, actually, I'm doing that backwards. We need to do 15 first. 15x. And then this is going to be 300,000. Now we can divide everything by 15. And the answer to that is 20,000. All right. Any questions? Now you don't necessarily have to reduce the decimal here or increase it out of a decimal. You could straight away use that. You could say 0.015 over 1 equals 300 over x. And you would have 0.015 x equals 300. You could absolutely do that. And when you divide, you would still get that x equals 20,000. Same answer. So it depends on whether or not you want to think of it like this and do the math, or you want to think of it like this and do the math. Doesn't matter. It's up to you. You're going to get the same answer regardless. All right, so let's move on to 6.3. We have another one here. Let's clear the page. Pause if you need to do so. All right, now problem states, an analysis of the old woman's utterances showed that 0.932 were vaticinal. If she spoke 2,000 times during the period in question, how many utterances were vaticinal? Now, you're going to get a vocabulary lesson for just a moment. Vaticinal is a word that means prophetic, of supernatural origin. Think prophecy, something like that. Okay, foretelling, fortune telling, just something prophetic or supernatural. So that's what vaticinal means. So 0.932 of her 2,000 utterances were vaticinal. So we can say that 0.932 of 1, you always use of 1 when you use decimals, or you can extrapolate that into 932 out of 1,000. Either way works. If she spoke a total of 2,000 times, how many were vaticinal? So we're looking for that 0.932 out of 2,000. Okay. So we just have to cross multiply. That's really all we have to do. So we have x oh, you know what? I made a mistake. This should say, no wonder. I'm sitting here looking at this and looking at this going, that doesn't add up. That's not the right answer. It's because it should say not vaticinal. Miss Tracy is not the best typer. So let's put this in here. We're not vaticinal. That makes what I'm seeing in the book much clearer as to why they got the answer they got. I'm just sitting here thinking to myself, that is not right. That's just not right. Okay, so they want to know how many were not vaticinal. So I didn't read that correctly. So if we need to know how many were not vaticinal, we need to say 1 minus 930.932. So we know what the total number is. And 1 minus 0.932 is going to be 0.068. So that's how many we need to know that were not vaticinal. So most of what she did was prophecy. Okay, kind of cool. If she's an actual prophet, which we, kind of doubt. Here we go. So this out of 2,000 times. So what we're looking for is this over 1. And we have 2,000 is our total, right? So x equals 0.068 times 2,000, which is going to give us a total of 136. Voila. That's your answer. Now, that is the benefit of using a decimal and not extrapolating into a whole number. You don't have to divide. You just multiply and it gives you the answer because this is a percentage. It's 6.8% of 2,000. So when you do that math, that multiplication, it's already doing the dividing for you. So you save a step. You could do it the other way. Now that we know we needed 0.068, you could say 1, 2, 3 and say 68 out of 1, 2, 3 equals X out of 2,000. Then you would just say 1,000 X equals 2,000 times 68, which would be 136,000. Then X. It's obvious that X is 136 because we drop the 3 zeros off the end. Same answer. It's just whichever way you need to wrap your head around it. Okay? Alrighty. Let's move on to consecutive integer word problems. I don't know if you guys remember the consecutive integers. That's where we would have a list of integers in a row, and we would do n plus 1, n plus 2, etc. for our consecutive integers. And when we would do consecutive odd integers or even integers, we would say n plus 2, n plus 4, n plus 6, etc. Right? Remember those? All right, we're going to continue. Let's clear this. Pause if you need to. Take notes. We're going to jump into 6.4. And we are going to do this one. It says, our instructions say, find 3 consecutive integers. Oh, even integers. Find 3 consecutive even integers such that 5 times the sum of the first and the third is 16 greater than 9 times a second. Let's take a little bit of shorthand there. Let's see if we can read my writing now. 3 consecutive even integers. So even integers, that means it's going to be n plus 2, n plus 4. Why do we use the plus 2 and the plus 4? Because they're even. So we're jumping over the odd numbers. We're skipping a number. So that would be like if we had 2 plus 2 would be 4, plus 2 plus 4 would be 6. So 2, 4, 6. Excuse me. Those may or may not be our numbers. I am just giving an illustration of why we use plus 2 and plus 4 instead of plus 1 and plus 2. It's because they're consecutive even. Oh goodness. I hope I'm not getting sick. I'm coughing. And my throat is sore. I might be getting a little, maybe it's just postnasal drip for allergies. I hope that's all it is. All right. Anyway, just know that this is the end of July, so I should not be sick during school. I should be over it by then if I have something. All right. So 5 times the sum of the first and the third. So we're going to say 5 times the sum. The first number is n, so it's the sum, so we're going to add them. And the third is n plus 4. Right? So the first and the third, the sum of the first and the third. All right? That's this line right here. Is, that's our equal sign, 16 greater. So that means we're going to add 16 to something. Then, that's what we're going to add it to. 9 times the second. So 9 times the second number is n plus 2. Okay? We follow along. 5 times, that's this 5 in the parenthesis, the sum, that's just plus sign, of the first and the third. So here's the first and here's the third. Is, that's the equal sign, 16 greater, so we're going to add 16 to something, then this is what we're going to add it to. 9 times the second number, and the second number is n plus 2. 9 times the second number. All right, that's our word problem, illustrated in an expression and an equation. So now we can solve it. So we're going to combine what's in here first, and this is going to be 2n, right? So 5 times 2n is 10n plus 5 times 4 is 20. Now let's distribute on this side. 9 times n is 9n. 9 times positive 2 is 18. And then we're going to add 16 to that. And when we add 16 to that, we're going to get 34. Right? Very good. So now we can flip-flop, as my son says. And let's take, because this is a bigger n, this is a bigger variable, let's bring the n over here and let's take the number over here. So that means we're going to have 10n minus 9n equals 34 minus 20. So n is equal to 14. So what that means is we have to take 14 and apply it to these. So let's do n plus 2. That's going to be 16, and n plus 4, that's going to be 18. So our numbers, our first, our second, and our third are 14, 16, and 18. All right, remember those? Is that jogging a memory for somebody? We have one more consecutive integer problem, and then we will be done with lesson 6. So let's clear the page, pause if you need to take notes, and then continue. We're going to do example 6.5. I'm going to type it for you this time. All right, here we go. Find 4 consecutive integers. All right, find 4 consecutive integers. So that's going to be first one, second one, third one, and fourth one. It's going to be n. They're consecutive, so n plus 1, n plus 2, and n plus 3, right? Such that 5 times the sum of the first. So 5 times the sum of the first and the fourth. So here's the first and here's the fourth. So the sum of those. So n plus 3. The sum of the first and the fourth is, here's our equal sign, 1 greater. So we're going to add 1 to something. Then, that's what we're adding it to, 8 times a third. 1 greater than 8 times a third. So 8 times, and the third is n plus 2. All right, so here's our problem. And let's solve it. So this is going to be 2n right here, right? So 5 times 2n is 10n plus 15. And then we have 8n plus 16 plus 1. That's going to be 17. So let's do our flip-flop. So 10n minus 8n equals 17 minus 15. So 2n equals 2, n equals 1. So our first integer is 1, our second integer is 2, our third integer is 3, and our fourth integer is 4. How cool is that? All right, if you have any questions or you did not follow along, maybe you want to rewatch that video and see how that worked out. That's all I have for lesson 6. I will see you guys in lesson 7.